Hello friends, welcome to the 8th video in the series of videos on Introduction to Swift. In this video, we will learn about optional chaining, typecasting, and extensions in Swift programming. Optional chaining. The process of querying, calling properties, subscripts, and methods on an optional is known as optional chaining. If the option contains a value, the property, method, or subscript call succeeds. If the optional is nil, the property, method, or subscript call returns nil. So you specify optional chaining by placing a question mark after the optional value on which you wish to call a property, method, or subscript if the optional is not nil. So this is very similar to placing an exclamation mark after an optional value to force the unwrapping of its value. The main difference is that optional chaining fails gracefully when the optional is nil because forced unwrapping triggers a runtime error in this case. For example, here we have a class called subject with an optional variable of type book. Book again has a variable called type. Now we create an instance of subject class and try to access the type variable for subject's book variable. So when we write sub.book, we get an optional type. Thus, we need to use exclamation mark to unwrap the return value and then use dot syntax to access the type variable on this unwrapped book variable. So while unwrapping, we could either use forced unwrapping by using exclamation mark, or we can just keep chaining the optional wrapping till end by using the question mark at the end of the optional variable, and then using the dot syntax to call the property. So as you can see here, first line with forced unwrapping prints maths as the output, and the second one prints maths wrapped in optional. So you can use optional chaining with calls to properties, methods, and subscripts that are more than one level deep. You can use optional chaining to call a method on an optional value and to check whether that method call is successful. You can do this even if that method does not return a value. You can use optional chaining to try to retrieve and set a value from a subscript on an optional value and to check whether that subscript call is successful. So when you access a subscript in an optional value through optional chaining, you place the question mark before the subscript's brackets, not after. The optional chaining question mark always follows immediately after the part of the expression that is optional. Multiple subclasses can also be linked with its superclass methods, properties, and subscript by using optional chaining. Typecasting. Typecasting is a way to check the type of an instance or to treat that instance as a different superclass or subclass from somewhere else in its own class hierarchy. Typecasting in Swift is implemented with is and as operators. So these two operators provide a simple and expressive way to check the type of a value or cast a value to a different type. Is operator, also known as type check operator, returns true if that instance is of that subclass type and returns false otherwise. A constant or variable of a certain class type may actually refer to an instance of a subclass behind the scenes. Where you believe this is the case, you can try to downcast to that subclass type with a cast operator. Because downcasting can fail, the typecast operator comes in two forms. The conditional form, as with a question mark, returns an optional value of the type you are trying to downcast to, and the forced form, as with an exclamation mark, attempts to downcast and force unwrap the result as a single compound action. So use the conditional form of the typecast operator when you are not sure if the downcast will succeed. This form of the operator will always return an optional value and the value will be nil if the downcast was not possible. This enables you to check for a successful downcast. Use the forced form only when you are sure that downcast will always succeed. This form of operator will trigger a runtime error if you try to downcast to an incorrect class type. For example, here we have a class vehicle and class bike and car inherit from class vehicle. Now we make three variables of each type of the class. Now if we try to print if car is vehicle, we get true because car class inherits from vehicle, thus car is a type of vehicle. But if we print bike is car, then we get false because bike and car, they do not have any direct is relationship with each other. As operator is used for casting a variable to another type. As followed by question mark returns nil when downcasting is not successful. That is why if we try to downcast bike to car, we get nil. Whereas trying to downcast bike as vehicle, it returns an object. That is, the casting is successful. Swift provides two special types for working with non-specific types. Any can represent an instance of any type at all, including function types. Any object can represent an instance of any class type. The any type represents values of any type including optional values. Swift gives you a warning if you use an optional value where a value of type any is expected. If you really do need to use an optional value as any value, you can use the as operator to explicitly cast the optional to any. For example, here we have an array of type any. So we can append any data type value to it. So as shown, we have appended some int, string, bike, car, vehicle values into this array. So now we can just iterate over the elements of this array and check which of them are type of vehicle by using is operator. Similarly, we can define an array of any object type, but we won't be able to append basic data type values in it. We can append only object types. Extensions. Extensions are used for adding new functionality to an existing class, structure, enumeration, or protocol type. Extensions in Swift can be used for adding computed instance or type properties, defining instance or type methods, providing new initializers, for defining subscripts and new tested types. Extensions can add new functionality to a type, but they cannot override existing functionality. For example, here we have added some extensions to integer data type. So if we access add property of an int, it returns sum of 100 and the integer value itself. Similarly for other operations also. We can access these new extended properties by using dot syntax. We can extend either computed properties or initializers or even methods. If you define an extension to add new functionality to an existing type, the new functionality will be available on all existing instances of that type, even if they were created before the extension was defined. That's it in this video. In next video, we will learn about protocols, generics, and access controls in Swift programming. Thanks for watching.